In this lesson, I'm going to show you how to solve problems involving a projectile fired at an angle that's less than 90 degrees but greater than 0. But before I do that, I want to briefly review some important facts about the motion of a projectile. First off, if a projectile moves without a significant amount of friction, the only force acting on it when it leaves the thrower's hand is the vertical force of gravity. Therefore, the horizontal velocity of the projectile doesn't change, but the vertical velocity does. The constant vertical force of gravity takes away about, well, not about, 9.8 meters per second of vertical velocity from the projectile for each second as it rises to the peak. After the projectile passes the peak of its flight, the vertical force of gravity adds 9.8 meters per second of vertical velocity every single second until it hits the ground. Since the vertical force of gravity is constant, the acceleration due to gravity is a constant negative 9.8 meters per second squared in the downward direction. This means that every second the projectile remains in the air, its vertical velocity changes by the same amount, negative 9.8 meters per second each second. This animation shows a projectile's horizontal and vertical displacement changes for an equal increment of time. The red lines show the projectile's change in its horizontal position each unit of time. The vertical force of gravity does not change horizontal velocity, so the horizontal changes in position are constant or unchanging. Notice on the way up to the peak, the projectile makes a smaller and smaller change in its vertical position. However, on the way down from the peak, a projectile makes larger jumps in its vertical position for each even increment of time. Let's look at a specific example. If a projectile started with an initial horizontal velocity of 25 meters per second and an initial vertical velocity of 40 meters per second, its horizontal velocity would remain at 25 meters per second the entire flight, but its vertical velocity would change. When a projectile hits the peak of its flight, its vertical velocity is always 0. When the projectile reaches the opposite side of its flight, it has the same vertical velocity it started out with, but now it's negative because it's pointing downward. Let's look at the projectile's horizontal and vertical velocity each second after it's thrown. To keep the math simple, I'm going to round up the acceleration due to gravity from negative 9.8 to negative 10. And now that's not allowed on your test, but it's a good thing to do when you're trying to learn. Since the vertical force of gravity only changes the projectile's vertical velocity, the horizontal velocity maintains its initial speed of 25 meters per second the whole time it's in the air. However, as soon as the projectile leaves the thrower's hand, the vertical force of gravity decreases the vertical velocity by 10 meters per second each second that it's in the air. At the peak, the vertical velocity is 0, and then for each second after the peak, after it passes the peak, the vertical velocity increases by negative 10 meters per second. So now let's try to solve a problem involving a projectile. Now an athlete doing a running jump leaves the ground at an angle of 25 degrees and a velocity of 10 meters per second. What is the initial vertical component of the athlete's velocity, which we call VIY? Here are two equations found on your reference table that you can use to find the initial vertical and horizontal velocities from the initial speed and the projection angle. Since we want to find the initial vertical velocity, we can use the first equation. When we substitute the speed and angle given, we get an initial vertical velocity of 4.2 meters per second up. Now let's use the same data to find the time it takes the athlete to reach her maximum height. Height is a vertical distance, or dy. It's also important to remember that the vertical velocity of the athlete at its maximum height, at her maximum height that is always 0 meters per second. All right, here's the deal. The key to solving projectile motion problems is to separate the vertical information you've been given from the horizontal. In the previous problem, we found out that the initial vertical velocity was 4.2 meters per second, so we can put that on the y side. The athlete did her jump on the earth, so the vertical force of gravity gives her a vertical acceleration of negative 9.8 meters per second squared. As I said earlier, projectile has no vertical velocity at the peak. We are looking for the time the athlete needs to reach the peak, so we write t equals question mark, and we could write that on both sides. The equation that fits the information that we have is VFY equals VIY plus AT. So we substitute the information we have and use a little algebra, and we get t equals 0.43 seconds to reach the peak. Well, let's try another question. How long did it take for the athlete to complete her entire jump? Since the total time equals double the peak time, since it took 0.43 seconds to get to the peak, then the whole trip would be 2 times that, or 0.86 seconds. Now let's find out how far the athlete moved horizontally before hitting the ground. To find dx, which is the horizontal distance, we need to use the total time the projectile remained in flight that we found in our previous problem. Since the only equation in the x direction is dx equals vx times t, we need to find vx by using v cosine theta from your reference table. So that would be vx is 10 meters per second times the cosine of 25, and then we next plug in that vx into this equation. You'll see it from the next slide. So here is the only x equation, dx equals vx times t. We found the vx using cosine is 9.1 meters per second, multiplied by the total time of 0.8 seconds, gives us 7.8 meters. In this lesson, you learned that the constant vertical force of gravity changes only the vertical velocity of a projectile. The vertical velocity at the peak is always 0. You also learned that in order to solve projectile problems, you must separate the vertical and the horizontal information. Then you must find an equation that fits either the vertical or the horizontal information. Oh, one more thing. Horizontal velocity is constant.